Hey everyone, welcome back to another CIE A Levels Maths past paper video. Today we're going to talk about mechanics for 2 variant from the May-June 2025 series. So let's jump into the paper. Okay, so question number 1. A crate is being pushed in a straight line along a horizontal surface by a force of magnitude 25 newtons inclined at 20 degrees above horizontal. Crate moves a distance of 12 meters in 8 seconds with constant speed. Find the constant speed of the crate. So speed is just displacement over time, distance over time. So V is equal to S over T. This is 12 over 8. So 4 times by 2, 4 times by 3. So this is like 1.5 meters per second. Find the work done by 25 Newton force. So basically what we have is this block and the force is 25 Newton inclined at 20 degrees to the horizontal. So this means that the component of the force in the direction of displacement is 25 cos of 20 degrees. Right, okay. So work done is force times by displacement, so 25 cos of 20 degrees times by 12 meters. So 25 times by cos of 20 times by 12, we get 281.91, so roughly about 282 joules. Find the power at which the 25 Newton force is working. So power is basically work done over time. So either we can do work done over time or we can do force times by velocity. Since it is constant velocity, so we have both of those things. So work done is 282. Actually 281.908 divided by, what was the time? 8 seconds. And this should be equal to 25 cos of 20 degrees times by 1.5 meters per second. So let's see. So work done, this divided by 8 is 35.224, which we can round it as 35.2, and this way, let's see what we get this way. So 25 times by cos of 20 times by 1.5, also the same thing. 35.238, again 24, which we can round it as 35.2. Alright, so let's move on to the next question. Question number 2. Two particles P and Q of masses 0.2 kg and 0.1 kg respectively are free to move in a straight line on a smooth horizontal plane. P is projected towards Q with speed 5 meters per second. At the same instant, Q is projected away from P with a speed of 2 meters per second. When P collides with Q, the particles coalesce. Find the kinetic energy lost during the collision. So, basically what's happening is you have an object P. The initial velocity is 5. The velocity of Q is 2, and after collision they coalesce, and we don't know the final velocity of that, right? So basically now we can use, first off we need to find out this, and only then we can find out the kinetic energy. So MP UP plus MQ UQ equals to MP, now they are being added, times by V. So mass of P is 0.2 kgs times by 5 meters per second, and since they're both moving in the same direction before, so this, and now 0.2 plus 0.1 times by V. So 0.2 times by 5, 1 plus 0.2, which is 0.3, so 0.3 V. So V is basically just 1 meters per second. So kinetic energy before and after we need to figure out. So kinetic energy before collision, total kinetic energy, sorry. So it's half mv squared, so half times by 0.2 times by 5 squared plus half times by 0.1 times by 2 squared. So 0.5 times by 0.2 times by 25 plus 0.5 times by 0.1 times by 4 is 27/10, which is 2.7. Now total kinetic energy after collision, so 0.3 times by 1, so it's just 3/20, which is 0.15. So joules. So kinetic energy lost is just going to be 2.7 minus 0.15, .55, and this is already in 3 significant figures, so that's that. Alright, so let's now move to the next question. Question number 3. A particle P of mass m kg is attached to one end of the light inextensible string of length 2.6 meters. The other end of the string is attached to a fixed point on a horizontal ceiling. The string is taut. The particle is held in equilibrium by a force of magnitude 35 newtons acting in a vertical plane which is perpendicular to the ceiling and contains the string. Okay. The force acts in a direction perpendicular to the string. See the diagram. Tension in the string is T newtons. The vertical distance of P from the ceiling is 2.4 meters. Okay. Okay. Find in either order the value of m and the value of t. So first we can draw a free body diagram to help with our understanding, or actually we can just simply do that over here. So this is mg weight over here, and this is the tension, like this. Now before we add or subtract forces, we need to know the angles. Okay, so if we can find out this angle using these two values, we can resolve the forces. And since there are just 3 forces and the system is in equilibrium, we can do the triangle of forces also. So let's try. Okay, first we need to figure out this thing. So this is sine theta is equal to 2.4, 2.6. So let's first simplify this. 12/13. Okay, we just need the value of sine theta and the cos theta. So cos theta would be, we can use the right angle properties. So we just need to know the ratio. So if this is 13, this is 12, this is going to be 5. Okay, now this would mean now that the horizontal component of tension is T cos of theta, vertical component of this is T sine theta, and this is theta plus 90, and we can figure out this angle also. And obviously, since this is theta, this is this is 90 degrees, this is theta, so this one would be 90 minus theta. So for 90 minus theta, this is the angle 90 minus theta. So for sine of 90 minus theta, whatever this 90 minus theta is, this is going to be 5/13, and cos of 90 minus theta is going to be 12/13. Sorry, we did not write over here. Oh, sorry, this is going to be 5/13. Right, okay, now we can figure this out. So, sorry, this one is 35 cos 90 minus theta, and one component would be over here, 35 sine of 90 minus theta. Okay, that's all what we need. So now, if we do the process with resolving the forces, it would be different, and if we do with the triangle of forces, it would be different. So I'll show you the alternate way also. So you have the sum of forces in Fy, T sine theta plus 35 sine 90 minus theta minus mg, right? So t we don't know, sine theta we do know, 12/13, plus 35 sine 90 minus theta is 5/13, and minus mg, m is m, and so this is g is 10, so 10m, this is equal to 0. Okay, so we can simplify this over here. This is 12t/13 plus 35 times by 5, 175 over 13 equals to 10m. We can multiply both sides by 13. We get 12t minus 13 times by 10, which is 130m, equals to minus 175. Okay. Alright, so this is the first equation. Now we need the sum of forces in Fx. So you have 35 cos 90 minus theta minus t cos theta is equal to 0. So this is 35, 9 cos 90 minus theta is 12/13 minus t is 5/13. Right, so cos theta is 5/13 equal to 0. So you get 5t/13 is equal to 35 times by 12, 420 over 13. So obviously 13 can get cancelled. Therefore t would be 420 divided by 5. This is 84. And if this is this, so we can figure out the 130m also. Actually, I think this would have been fine, so we can rearrange this. 130m is going to be 12t plus 175. So 12 times by 84 plus 175. So therefore m would be 12 times by 84 plus 175 divided by 130 So this is 9.1. Now, what would the case be if we use the triangle way? So I'll do this over here on this side over here. So we had mass downwards, mg, 10m. How was it? 35 was going this way and tension was going this way. So 35 is going this way and tension is this way. Okay, now this is 90 degrees. This is now 35 and this is our T. Okay, now we can deduce the angles from over here. So according to our previous work, this is theta, so this would be the 90 minus theta, right? Like if we just consider this as a small triangle on its own, and the same way this would be 90 minus theta and this would be theta. Now we have the ratios, we already just calculated them over here. Now we just simply need to use the sine theorem over here. So 10m over sine 90 equals to t over sine theta equals to 35 over sine 90 minus theta. Sine theta is 12 over 13. So sorry, wait. Sine 90 is 1. This is 12 times by 13. And this is 35, 5 over 13. Okay, so let's see what we have. Okay, let's see if we get the same answers or not. So first we do this. No, sorry. First let's do these two, because first we need one of them. So t 13t over 12 equals to 35 times by 13 over 5. So 13 gets cancelled. 5 times by 7. So t is equal to 12 times by 7, which is also equal to 84. Now this one, 10m, is equal to 35 times by 13 over 5. So this would be this thing, right? So 35 times by 13 divided by 50. This is 9.1 also. And that's about it. Okay, so same answers. Right, okay, now moving on to the next question. Question number 4. A car is traveling along a straight horizontal road. The car passes through point A on the road traveling at a speed of 15 meters per second and then accelerates uniformly at 0.4 meters per second squared for 30 seconds. The car then moves at constant speed for 3t seconds, where t is less than 30. The car then decelerates uniformly at 0.2 meters per second squared, and after further t seconds passes through a point B on the road. On the given axis, sketch the velocity time graph for the motion of the car between points A and B. Okay. So it's traveling with 15 meters per second. Let's make 15 over here. Okay, so it then accelerates uniformly for 30 seconds. So let's say this. Sorry. we can make a different color. This is 30 seconds. It moves at constant speed for 3t seconds. So actually, sorry, wait. So somewhat like this. 3t means almost 3 times by that. So sorry, no, wait. So less than 3 times by that, right? So somewhat like this. This is your 30. Okay. And this, the duration for this thing is 3t. So this would be 30 plus 3t. And then it decelerates uniformly at that. So the deceleration is half the acceleration, so lesser gradient. And after a further t, right? So almost like this. Actually a little bit further. And like this. Okay. So this would be 30 plus 40, you can say. Okay. Right. We need to be specific about these things now. And we can't be specific because they haven't given us anything more than that. So that's basically it. We can definitely make these lines dotted. So okay. Okay. Right, okay. The distance from A to B is 2750. Find the value of t. So now we need the area between these. And for that we will need this final speed. So this would be 15 plus 0.4 times by 30. So 15 plus 0.4 times by 30, this is 27. Okay. Right. So 30 seconds. Right. Okay. So this is 27. So we need total distance. Okay. So this is half times by 15 times by 15 plus 27 times by 30 plus this duration is 3t. So 3t times by 27 plus half times by actually we would need to figure this out. This would be over here, it's 27 and minus 0.2 t, right? So 27 plus 27 minus 0.2 t times by t, right? Okay. And this is, first we need to simplify this. So 15 plus 27 is 42. 42 divided by 2. Sorry, half times by 42 times by 30 plus 27 times by 3 is 81. Sorry, 81 t. And this is half times by 27 plus 27. So 54. Yeah, 54 minus 0.2 t times by, let's say, t. So 42 times by 15, this is 630, plus 81t plus t by 54 divided by 2 is 27. 27t minus 0.1 t squared. And okay, no, first 630 plus 81 plus 27, 108 t minus 0.1 t squared is equal to 2750. So now this can be converted into quadratic equation. So 0.1 t squared minus 108 t, and then 2750 minus 630. So 2120 equal to 0. So multiply by 10 on both sides, so you will get t squared minus 1080t plus 21200 equal to 0. Alright, now the quadratic equation. So minus b 1080 plus minus 1080 squared minus 4ac, so 4 times by 21200 square root divided by 2. So 1080 plus square root of 1080 squared minus 4 times by 21200 divided by 2. So one answer is 1060 and the other answer is 20. Alright, now they said t was less than 30, so obviously this is going to be 20. 30, so therefore t is 20. Okay. The car continues its journey from B, decelerating uniformly at 0.5 meters per second squared until it comes to rest at a point C on the road. Until it comes to rest, find the total distance from A to C. Okay, so from this point, it then decelerates at a faster rate coming to rest. So this is now going to be 0.5 meters per second squared coming to rest. So right, so we know the velocity over here, so if we can find out this time, we can add it up with 2750. Right, so what do we do? Okay, so right, so v is equal to u minus at. So v, sorry, is u, v is 0, u is 27 minus 0.2 t minus at 0.5 times by 20. Right, so 27 minus 0.2 times by 20 minus 0.5 times by 20, that was 10, sorry, 20, 30. Oh no, sorry, no. Wait, no. This was the unknown, no? This was the unknown. Sorry, my bad. This is 23. Right. 0 is equal to 23 minus 0.5 t. So therefore 0.5 t is equal to 23. T is 23 divided by 0.5. This is just 23 times by 2, 46 seconds, right? So distance in the last 46 seconds, this is going to be half times by 46 times by the deceleration was from 23 to 0. So actually it would be just 23 times by 23, so 529. Total distance would be, this is from B to C, by the way. Okay, so total distance from A to C is 2750 plus 529. $32.79 meters. Since this is now an exact numerical answer, it's not a non-exact one. There's no decimal thing. This is an exact numerical answer, so we don't need to round it to 3 significant figures. Alright, so let's move on to the next question. Okay, so question number 5. One end of a light inextensible string is attached to a particle A of mass 3 kgs. The other end of the string is attached to a particle B of mass 4 kgs. Particle A is in contact with the rough plane inclined at 30 degrees to the horizontal, and particle B is in contact with a smooth horizontal plane. A second light inextensible string is attached to B. Okay, so that means the tension is not the same in A, B, and BC. Alright. The other end of this string is attached to a particle C of mass 5 kg which hangs vertically. Both strings are taut and pass over a small smooth pulleys that are fixed at the ends of the horizontal plane. Part of the string from A to the pulley is parallel to the line of the greatest slope of the inclined plane, and A, B, and C are in the same vertical plane. The system is designed from rest. In the subsequent motion, C moves vertically downwards with acceleration 2 meters per second squared, and neither A nor B reach a pulley. So basically this is a connected particle system. So, okay, alright. So we need the equations of motion for 3 objects. And tensions in A, B, and BC are different. Okay. So this is 50 newtons. Sorry. And this is, let's say, tension BC. This is tension BC. And this is tension AB. This is tension AB. And this is going to be 30. 3 times by 10 sine of 30 degrees. Right? Okay, alright. So we start with C. 50 minus tension BC is equal to 5A, 5 times by, sorry, they gave us that, right? 5 times by 2. So tension in BC would be 50 minus 10, which is going to be 40 newtons. For B, we have tension BC minus tension AB equals to, the mass of B is 4, so 4 times by 2. So TAB is going to be TBC, 40 minus 8. So this is 32 newtons. And now for A, TAB minus 30 sine 30, basically this would mean this is just 15, equals to A is 3 kgs, so 3 times by 2. So TAB, no, wait, sorry, wait. Find the tensions in each of the strings. Okay, we already have that. Okay, alright. We don't need this. Alright. Okay. Find the coefficient of friction between A and the inclined plane. Okay. So over here we would need that, and I completely forgot that this was an inclined plane problem, and sorry, friction problem. So this one would be 30 cos of 30 degrees, the reaction force basically, right? And since this is going upwards, friction would be acting this way. Okay. So we need the sum of forces, right? TAB minus 30 sine 30 degrees minus 30 cos of 30 degrees times by mu is equal to 3 times by 2. So TAB we found to be 32. 30 sine 30 is 15. 30 cos 30. See, cos 30 is basically under root 3 over 2. So 30 under root 3 over 2, mu times by 6. So 15 root 3 mu is equal to 32 minus 15 minus 6. So 32 minus 15 minus 6 is 11. So mu is 11 over 15 root 3. So basically 11 root 3 over 3 times by 15, 45. So 11 square root 3 divided by 45. We can leave it like this also, but we can see now this is a non-exact answer, so 0.423 would be appropriate. So both answers are obviously correct. So since this is like the maths exam, so leaving it in the exact form would also be perfectly fine. Okay. When the system has been in motion for 1.5 seconds, the string attached to A breaks. Find the total distance that A travels up the plane from the instant that the system is released from the rest to the instant that A comes to instantaneous rest. Okay. Now what it means is that it will not come to rest when the string breaks. Okay? It will continue moving up. So distance until string breaks. Okay, so this would be S is equal to there is no U, right? Since they are released from rest, so S is equal to half a t squared. So U plus half times by 2 times by 1.5 squared. So 1.5 squared, because obviously 2 times by 2 just simply cancels out. So this is 2.25 meters. Now the distance until instantaneous rest. Sorry, distance from string break to instantaneous rest. Okay, so first we need to figure out what the what the acceleration is, right? So when you take away the forward force, you have the 15 Newton downwards parallel force and friction force which we did not figure out, but we can figure out, mu r, right? So first we need to do that. So acceleration is equal to 15 plus mu r, mu is 11 root 3 over 45 times by 30 cos 30 root 3 over 2 divided by 3. Right? Okay, so 15 plus 11 square root 3 divided by 45 times by 30 cos of 30. So this is just 26 divided by 3. We can keep it like this because we need the acceleration. So s is equal to half. Right, okay. No. Ut plus half at squared now. We don't know the distance. Oh, we don't know the distance. Okay, alright. We don't know the distance, so we will use the 2as is equal to v squared minus u squared. So s would be v is 0 minus u is, actually we need to figure that one out also. Right, we can do that. So v is equal to u plus at, 0 plus at times by 1.5. So 2 times by 1.5. d squared divided by 2 times by negative 26 over 3. Okay, so you have 2 times by 1.5, this is just 3 squared is just 9, divided by 2 times by 26 and times by 3. So this is 27 over 52. So total distance would be 27 over 52 plus 2.25. So this plus 2.25 is 36 over 13, which can be rounded to 2.77. Okay, alright, so let's move on to the next question. Question number 6. A particle P moves in a straight line and passes through a point A at time t is equal to 0. The velocity v meters per second of P at time t seconds is given by this. Find the maximum velocity of P in the interval 0. So basically that means we need to do the dv over dt. So this would be 3 over 2t plus 1 half times by 2 chain rule minus 4t. And then we make it equal to 0. Okay. So we get 3 over 2t plus 1 raised to power 2 times by 2, this would be just cancelled out, equals to 4t. We can square both sides. Sorry, this. So this would become 9 times by 2t plus 1 equals to 16t squared. So t, we need to find out t obviously first. 16t squared minus 18t minus 9 equal to 0. So I think we can figure out factors. 4t, 16t squared minus 9 minus 18, so 3 no. Wait, no. What if this is 3 and 3 and this is 2 and 8? 24 minus 6. Yes, this is going to be correct. So 24 is negative, 8 times by 3, this factor is negative. So you have 2t minus 3 and 8t plus 3 equals to 0. So obviously we cannot have a negative time, right? So this one would be correct. So, and it is in the 0 to 3, right? So now we just plug this into the value, time into the velocity function. So 2t plus 1, 2 times by 3 over 2 is just 3 plus 1. 3 by 2 minus 2, 3 over 2 squared. So 4 square root 2 is just 2, 2 cubed is just 8, minus 2 times by 9 over 4, so just 9 over 2, so 16 minus 9 over 2, so 7 over 2. Okay, so maximum velocity, (7 over 2) or 3.5 meters per second. Okay. It is given that in the interval 0 to t to 3, the velocity of p is always positive. Find the distance of p from A at the instant. Wait a second. Of p from A at the instant when p is moving at the maximum velocity. Okay. So we need to integrate v. What was the expression? 2t plus 1 3 over 2 minus 2t squared dt from A, that means from 0 to 3 over 2. Right? Okay, so now we integrate this. 2t plus 1, 5 over 2, divided by 5 over 2 times by derivative of 2t plus 1, minus 2t cubed over 3, divided by 0, 1.5. So this 2 and this 2 will just simply get cancelled. So you have 2t plus 1, so 2 times by 1.5 is just 3, plus 1, 5 over 2, minus 2 over 3, 1.5 cubed, minus, wait, sorry, there is a 5 over here, right? And then you have 2 times by 0, so 1 over 5, minus 0. So 3 plus 1, 4, 4 square root 2, square root is just 2, 2 raised to the 5 is 32 over 5, minus 2 divided by 3 times by 1.5 cubed is 9 over 4, minus 1 over 5. So 20, 32 times by 4 is 128. minus 4 minus times by 5, 45. So 128 minus 4 minus 45 is 79 over 20, and I think that's it, but we can actually figure out the non-exact value also. This is 3.95. And okay, now let's move on to the next question. Question number 7. A particle P of mass 3 kg is projected with the speed of 8 meters per second up a line of greatest slope of a rough plane inclined at an angle 30 degrees to the horizontal. P is projected from point A on the plane and comes to instantaneous rest at point B up on the plane. P then slides back down the plane. The coefficient of friction between P and plane is 1/12 root 3. Okay. Using an energy method throughout, find the speed of P at the instant it returns to A. Okay, so basically when it is going up, right? When it is going up, there is work done against. There is the initial kinetic energy given, right, is going to convert into the change in gravitational potential energy. So the kinetic energy given, so KE or EK, whatever you want to write it as, obviously the change in EK we are talking about because it's coming to rest at point A, at point B from let's say from A to B. Okay. Equals to change in EP, gravitational potential energy, mg delta H. This is your delta H, and plus work done against friction. So work against friction. So basically this takes, this is like force times mu r, right? So mu r. So this can help us find the r, which is going to be the same moving back also. So initial kinetic energy given is half times by 3 times by 8 squared minus 0. That means the change in kinetic energy from A to B, right? Height mg, so 30. This is 30 degrees. So there is, let's call this distance s. So this is this also. So 30 s sine of 30 degrees plus mu r s, so under root 3 over 12 times by r. We already know what r is going to be. That is going to be 30 cos of 30 degrees, and times by s. Okay, this is helping us find s. Okay, alright. So 0.5 times by 3 times by 64, 96. 30 times by sine of 30, this is 15s, plus under root 3 times by 30 cos 30. cos of 30 divided by 12, 15 over 4, s. Okay, so therefore, let's say this is 4 over 4. So 4 times by 96, 384, equals to 4 times by 60 plus 15 s. So s is basically 384 over 75. 5.12, so 128 over 25, which is 5.12. Okay, so this is the where s is distance along the plane covered. Okay, now we need to bring it back from B to A. Now there is no other force now, it's just the weight component and the friction that will be in other direction. So the work done by gravity in this time, like the change in gravitational potential energy, or I think we can actually say change in kinetic energy again, is the loss in EP, but this time it's going to be minus because we work against friction. Work done against friction, right? So work against the friction would be the same as we had over here. So I think we can calculate that. So square root 3 divided by 12 times by, no sorry, we already calculated this, 15 over 4s. So 15 divided by 4 times by 5.12, 19.2. Okay. So this is what we need. So change in kinetic energy would be half times by 3 times by v squared, loss in the gravitational potential energy. It is the same, right? 15s, right? S is the same, 5.12 minus 15 over 4 times by 5.12. Previously, this kinetic energy was actually used in raising the potential energy and the work done against friction also, but this time it is taking away from it. Okay, so now I think things are a little bit clearer this time. So your V squared is going to be, right, so let's calculate that. So 15 times by 5.12, 76.8, 3/2, minus 15 times by 5.12 divided by 4, 19.2. So 76.8 minus 19.2 times by 2 divided by 3 is 38.4. Okay. So therefore P is 6.196. Actually it would be 6.20 meters per second. Therefore, final speed of P at A is 6.2 meters per second. And let's see. Okay, alright, so there's no more part. That means this is the end of this paper. I hope you enjoyed solving this paper with me. If you have any questions, confusions, or doubts, feel free to reach out in the comments. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. If you would like some one-on-one coaching for preparation for May-June 2026 exams, feel free to reach out. The links are given below. You can just straight away contact through the WhatsApp link. And until the next video, take care. Bye-bye.